Welcome to everybody. Welcome to the new appointment with the Milan Power BI User Group webinar series. Today we are proud to have with us Razor Red, and with me there are also Riccardo Perico and Francesco De Chirico to manage and to introduce our guests. Riccardo,
good morning, good evening. I don't know which is your time zone, so welcome to a new webinar from Power BI User Group of Milan. Thank you, everybody, and just few information for you. Today we are using Teams Live event. And as usual, you have the Q&A panel active, so you can interact with the speaker, just asking your question in the Q&A panel. And as usual, we will collect the materials if possible, and we will create a library in our user group site, so you will be able to get all the materials directly from the QR code that you are seeing right now. As usual, we are recording the session, so it will be available on our YouTube channel, so you can see it again, or you can view it if you missed it. We are also pushing our meetup channel, so if you are interested to see all the events that we are going to organize, please get in contact with us directly with the meetup. Just a few words we would like to say thank you, everybody, because this is our 14 non-stop weekly events. We had more than 10 speakers and coming from 3 different countries, and today, thanks to Reza, we can say that we delivered a session from also 2 different continents. So thank you very much, since we reached more than 100 subscribers on YouTube and more than 1,700 views on YouTube. Thank you very much. Also, our Milan user group grew about 50%. So thank you very much for this great run. Just a few news. We will have on Thursday the 16th Mark from the Netherlands that will talk about artificial intelligence in Power BI, so don't miss it. That's it. Thank you very much for being here, and now it's Reza's turn. Thank you very much, Reza, to be here. Please share your desktop. We will give you the presentation rights.
Sure. Thank you for the opportunity. Thanks, Riccardo, Lorenzo. Let me just make sure everything is sorted. Yep. Thanks, Riccardo, Lorenzo, Francesco, for the opportunity, and thank you everyone for joining. This session is about basics of writing DAX. This is like a very, let's say, basic level, 100 level session. We won't talk about advanced features. We just talk about like very basic introduction for those of you who are new in writing DAX expression, how you can do that. About me, I'm Reza Rad. I'm based in New Zealand, the other side of the world. Right now it's morning in actually Friday, your evening, Thursday, here is Friday morning. I'm author of some Power BI books. One of them is free, available in our website, in Red Hat website, Power BI from Rookie to Rockstar. I'm a blogger and has some blog content in our website. And some videos, YouTube videos as well. Feel free to reach out to me if you have any questions with my my contact information down below this slide. Now, I don't really have much of a slide. I just have 3 slides. This was the second slide. The last slide is the slide to wrap up. My presentation is mainly demos, and that is what we are going to do now. So talking about DAX, this is a Power BI solution I'm going to work with, and I'm going to get data from a sample AdventureWorks dataset, which you can download this Excel file from my blog. Everything that I present to you today, you can find blog articles, Power BI file, everything related to that in Radicat blog. Everything is available there. So let's say I'm going to build a Power BI solution here using a few tables, let's say customer table, product table, and sales table. I'll start with these 3 tables. Now, I'm not going to talk about how the relationship works and things like that for this example. We are just focusing on the way that writing measures and DAX expression works. By the way, I will just show you how the relationship diagram look like for this example. I have the sales table, which is kind of my transactional table, my fact table, and I have 2 dimensions, product and customer table, and they both filter the sales table. Now, talking about measures in DAX or in Power BI, basically, there are a bunch of calculations you can add in Power BI. One of them is a measure. A measure is a calculation that you write in Power BI. You write the definition of that calculation, but that doesn't show you the result of that calculation in the data view. For example, if I create a new measure here, and this is how I can create a measure. I see this formula bar. I can call this measure, let's say, something such as sales. And I can start writing this measure calculation. Now, because we are talking about the language here, and that language is DAX, it's important to understand how to write calculations in DAX. For example, if I'm writing a measure, my measure, one of the key points here is that a measure should return one single value. I cannot have a measure that returns like a whole table or a column. So I cannot say, for example, that this equals to sales amount. This is not possible. You see, the IntelliSense doesn't really show me the column name. When you are typing something and this IntelliSense or pop-up menu, whatever you might call it, doesn't show you that function name or the thing that you are looking for, that means it is probably not the best place to write it. There are a few exceptions, but able to say this equals to sales amount. Also, I'm in the same table. I'm in the fact internet sales table, but still I'm not able to say give me the sales amounts. The reason is that in this table we have so many rows, like 60,000 rows. If I say sales amount, and there is a column for that, just to show you, here it is. If I say sales amount, it doesn't really make sense. A measure should return one single value. When I say this equals to a column, this cannot return one single value, right? So I should write my calculation, my expression, in a way that returns one single value. That means I should use some functions, and there are many functions here. You can see just a few of those that start with S in this example. I can use any of these functions that returns one single value and use it to produce my measure. Now we have 2 sets of functions. We have a set of functions that return a single value. We call them scalar function, and we have a set of functions that return a whole table, and we call them tabular functions. Now, for example, sum is a function that is a scalar function. And when you choose a function here, you see the definition explains that. So sum is a function that adds all the numbers in a column. So the input of this function is a column name. And then I would see all columns that I can use as an input. Sales amount is one of those as well, right? The column names usually comes inside the square bracket, table names before that. If table name have a space, there would be like a 2 single quote around it as well. So I can use sum of the sales amount like that and close bracket, right? Now, because sum returns one single value, this would be a totally valid expression. And when I press enter, this creates my measure perfectly fine. Here you can see my measure. But then the thing is that this measure, I cannot see the value of that here in my data tab because the measure is not yet evaluated. It is just created. I've written the expression for that, but the measure is not evaluated. That means the measure is not showing me the result. How do you see the result of a measure? In Power BI, you have to go and add it in a visualization. There is no other way to see what is this measure's value. I can come to this visualization here. For example, I can bring that sales measure here as a table, let's say. And I can see this is $29 million. Let me change this font size, everything a little bit bigger, so it's easier to see. And by the way, if you have any questions, feel free to write it in the chat window or in Q&A. Okay, so this is my sales data, right? My sales measure. $29 million. So how did it work? It gave me sum of the sales amount across the entire table. Is it always like that? No. For example, if I have in this table, if I have something from customer table, as an example, education from the customer table, then it returns different thing. Here it returns 9 million for bachelor, for graduate degree 5 million. It's the same measure, but it returns different thing for every different value here. And the total is $29 million. This means that that measure evaluated here 6 times, right? Why 6 times? Because 5 times for this, for these values and 1 time for the total. Total is not actually sum of those. Total is calculate sum of sales when there is no filter. That is how you should read it. And that is one of the reasons that sometimes you see total is different from what you expect this to be. So 6 times calculated, but everything happened fast because measure calculation happens in on the data that lives in the memory, and the calculation itself uses the CPU power to do the calculation. So it happens really fast. But you have seen that the calculation can be different. It is not pre-calculated. You cannot say sum of sales amount is always $29 million. It might be different. What you see here is showing that exactly. Now, everything impacts this, not only filters on inside this visual, not only this column. If I have a slicer, let's say, and the slicer is a gender slicer. If I select female, you see all of these numbers are changing. So that means that sum of sales amount is not affected only by English education here. It is only affected. It is also affected by gender that comes from a filter, from a slicer. I might have also a filter. Let's say I'll bring the product color from the product table. This time I bring it as a filter on the page. And I choose, for example, black. And again, you see everything is changing, right? So everything affects this calculation, sum of sales amount. I didn't set sum of sales amount where the color is black or where the gender is female or where education is partial college or anything like that. It considers all of these automatically. This means something. This means that all of the filters you apply inside your report page, inside your visualizations that affect this visual is building the filter for your calculation. This concept is called filter context. Filter context is any filters applied either in this visual or other visuals that affect this visual, which can be like a slicer, filter, other charts or visuals, or inside this visual. All of those build something that that this calculation is based on, which is a filter context. Measures are always dependent on the filter context. Whatever you write works on top of the filter context. So it is the filter context that derives the result of this, and that always evaluated runtime. Like, for example, if I unselect female, runtime, everything changed and this calculation changed, right? So these are all basics and things that you might have known already. But the thing is that when you start writing your measures in a more complex manner, when you start to write complex measures, sometimes you forget about this filter context. It's a very important, very basic concept, but it's a concept that you should not forget, because based on that you can write correct measures. Okay, now that I've talked about, let's say, filter context, which is one of the main concepts of the measures, let's go back to the way that measure is calculated. So here I had the measure, which was sum of the sales amount, and you can write your measures in this view or data view, that doesn't really matter. So this is sum of sales amount. Now let's say I'm also interested to show here the sales minus cost, something like a profit. I want to show that, or margin. Let's call that margin. So I think that I can go and create another measure. And in this measure, I can say, let's call this margin. Margin, and I'm trying to say sum of the sales amount minus cost. But if I do that, you see nothing really happens for the second part of the expression. It doesn't bring that pop-up menu. Now think about it for a second. What we are trying to do here, we are saying that sum is the function. As the input of that function, we are saying sales amount as a column minus cost, which is another column probably. But does sum accept that? No, sum only accepts one column name. I cannot say this column minus that column. That is not a column name. So that means that this is a limitation of this function. What you can do instead, you can say sum of the sales amount minus sum of the cost, total product cost in this example. Something like that is possible. And I can even use the measure that I had there, sum of sales amount. I already have that defined as a measure as a sales, so I'm going to just use that sales, right? You see, when I use a measure inside another measure, it shows this purple color. So I can use a measure inside another measure, and it's absolutely fine. But the thing is that, like, this is not the only way of doing this. Sum of this minus sum of that. There are other ways as well. Another way to do this is using a different function that accepts something as a calculation, right? As an expression, not a single column. Because the problem with sum is that it accepts only one single column. As an example of this, I'm showing you sum x function. Now, I'm not saying that you should be using sum x instead of sum whenever you want to use two columns in your expression. I'm just showing this as an example to introduce this function to you. Sum x is a function that has two inputs. Always look at the definition of these functions. Two input. The first input is a table. And the second input is an expression. The second parameter is an expression. This is not asking about a column. This is asking about an expression. So I can easily go and write an expression here. Now, what the table is, this is the table that the expression is coming from. Because in my example, both of these columns, the sales and the cost, they both come from sales table. This can be sales table. In DAX expression, you can even go to the next line using Shift Enter and things like that. I highly recommend using a tool like DAX Studio to write your DAX expression and DAX formatter to format your DAX expression much better. But for now, we are just showing everything in this Power BI desktop environment. So my table is sales, fact internet sales. Yep, that was the right one. As an expression, I want now the sales amount minus total product cost. But here, because this sum x overall across this table will apply the expression. I don't need to write sum of the sales amount minus sum of the cost. I can easily say sales amount, because I'm in the context of that table, and this would apply summarization at the end, so my measure should work anyway. Sales amount minus cost. All product cost. Yep, here it is. And then close bracket. So this is my expression, sales amount minus total product cost. I can even remove the table name before the column names because I'm in that table. However, having the table names before column names is not a bad thing. It helps to make your code more readable. Having table names before measure names is not ideal. I don't recommend that, but having table names before column names is fine. So this now would work just fine because this is an expression, the second parameter of this formula. This is the formula, the table itself. Right. When I press enter, now I can bring that calculation margin over here, and it would work just fine. Right. Just to show you that it is working fine, I'll bring cost into this so you can see this is sales minus cost. Here it is. Bringing cost right before margin. So sales minus cost, and this is the margin. Right. So that's how margin calculated. Now, this function is a specific function in DAX. We call it iterator, part of a category of functions. We call them iterator. Why iterators? Because the way that they work with an expression. They go through every record in this table, fact internet sales, the sales table. For every record, they calculate sales minus cost, store it in a temporary storage. Then the second record, sales minus cost. The third record, sales minus cost. At the end, because it is SUMX, it summarizes all of those values together, release the temporary storage, and show you the final result for every one of these. Because it iterates through every row in this table, we call them iterators. They have their own benefits, especially for calculating totals and things like that. This is only like one of the use cases that you can see that I can use an expression here rather than just a column name. They are quite useful, but sometimes you have to be careful the way that you are using it because their calculation might be a little bit bad for the performance because it goes through every single row. Now, this is also a scalar function. SUMX is a scalar function because it returns one single value. After all of those calculations, it returns one single value per combination of filter context that I apply. Now, let me explain another function which is not a scalar function. What you can do with those functions. If I go ahead and create a new measure, I'm just going to call it measure for now. There's a function called all, right? Or some other, let's say, variations of this function as well. Now, all is a function that accepts parameters, and whenever you see these parameters are inside a square bracket, this means they are optional. So this means that I can use all even without any parameters. I can use it just like this, or I can use all with a table name or column name accompanied by other column names, right? So I can use all like that. But what all returns? It returns all rows in a table. It does not return one single value. For example, if I say all of my fact table, this does not return one single value. This returns the entire table. So as a result, I cannot use this in a measure because in your measures, you should have scalar functions. If you have a function that returns a table, you get an error, something like this. Multiple columns cannot be converted to a scalar value because your measure expecting a scalar value. This is returning a table with multiple columns. Right. So then what is the usage of functions like this. The usage of functions like this is that you can use them inside other functions. For example, in any functions that there's a table expected, I can use this inside that function. Let me show you that as an example. So you already know that SUMX, going to this measure, the measure that was SUMX margin. Yep. You already know that SUMX is a function that has two parameters. The first parameter is a table. The second parameter is an expression. The first parameter here is a table, and that doesn't mean that this should be like a physical table in your model. This can be a function that returns a table. You can actually cascade that function inside this function. That is how we write DAX statements. One function produce something, the result of that used in another function, the result of that used in another function, and this goes on and on. Now, this is the same case. Here, I can use a function result that returns a table. And in this case, my function that returns a table can be all of something, right? So I'm going to build that into that new measure that I've been working with. So instead of saying that this measure is equal to all of sales, I can do it this way. I can say SUMX table can be this. That's the first parameter. Then I say sales amount. I can say sales amount minus total product cost, but let's start with that so I can show you the difference. And I'm going to call this sum sales all. Right? So sum sales all, what it is doing, and you see there, I don't get any errors for this. This is absolutely fine. It gets a table, and my table in this case is all of this part, all of fact internet sales, and then my expression is just sales amount. So it means that this function will go through this table and will get sales amount for every row. Then at the end of that, it will summarize all of those together, right? This looks pretty easy to understand. Now I'm going to add that into this table, and then you would understand what this all function itself is doing, because so far we haven't talked about what this function is doing. We just talked about how to use it, right? So I'm going to add this into this visual, and I'm putting that beside the sales column so you can compare these two beside each other, this one and that one. Now you see that this expression is returning $29 million sales regardless of which English education category we have. It is $29 million for any of these. And that $29 million is actually our grand total, because if I unfilter the things here, and in my slicer, yep, here you can see it, that $29 million is the total here. And that $29 million is what you see over here. So what happened here is the effect of that function we have used, all, that is causing this. Let's go and look at the function definition. When we use all, like one of the ways that you can find the definition is remove that bracket, open it again. Now you can read the expression. It says return all rows from a table, in a table, or all values in a column, ignoring any filters that might have been applied. And this is important part of this function to understand. Now, where is filters? These filters are actually your filter context. Anything coming from a filter in the report, in the visual, other visuals, filters, slicers, inside the same visual, other columns that filtering this, all of those would be ignored for this. And you might wonder, what is the point of then using a function like this? Well, the point is you can use it to calculate total in a case that you want the total to be calculated. Like, for example, imagine you wanted to say, give me the percentage of the sales from high school category versus the total. How would you calculate such a thing? in DAX, because whenever you say give me sum of sales, this will give you only sum of the high school sales. It never gives you this, because when you are in that context, when you are in the context of high school, everything is filtered for high school, so sum of sales would be high school. You cannot say sum of sales divided by sum of sales. That doesn't really make sense. That would be always 100% because that's 4 million divided by 4 million. You should have a way that when you are in this context, when you are writing a measure within the high school context, it still returns the total. And this is exactly how you can do it. One of the ways you can do it. You can use a function like all, which means that I know you are in the high school context, but I don't care. It's like a wall that nothing passed through this wall. It says that I don't care you are in high school context. I just give you the total. And then you can say this divided by that give you the percentage. You can, let's not say manipulate it, but you can play with this filter context. If you don't want the filter context to affect your calculation, you can use functions to do so. And all is one of those functions that can ignore these filters. There are many other functions as well. I'm just working on basics for now. So this means that this will always return this. And if I have a percentage, just another measure, let's try. If I have a percentage, let's call it sales percentage, that can be the sales divided by, what did I call the other measure? Sum sales all, and I should call that total sales basically, because that is what it means. Now, when we divide one value by another value, it's fine to divide it like this, but in case that your second value might return 0 and then you might get an error of infinity, it's a good idea to use a function like divide instead. If you expect divide by 0 happens, otherwise you can just do the normal divide because that's usually just a little bit faster. So I can say divide this value by that value, use comma instead of divide operator because I'm using the function, and I can provide the alternate result. Like for example, this means that what happens if divide by 0? I can say, for example, divide by 0 happened like that, or you can just leave it if you don't really add anything there. That returns blank. At least it doesn't return an error, right? So if you expect an error, this is a better way of doing divide rather than that way. Okay, I'm going to use this measure now in here, percentage. I'll bring it here and you can see the percentage. So using that function with all was helpful because then I can calculate this percentage. Versus if it was without that, I couldn't get the total there. You might say total is here. Yep, you can see it, but always look at the context of that row. Within that row, you want to calculate the total, and within that row, you want to have the row value divided by the total to give you this. Right? All is only one of the functions that returns a table. There are plenty of other functions, and even all itself has many variations. I still don't see any questions, so I just continue on the session. All has different variations. For example, here you can see that even if I go and choose a filter here and say product is black, still my sum sales is $29 million, right? My other value is changing, my normal sales is changing, but the total sales, let me rename that to be called total sales. Sum sales all is not a really great name. If I call it total sales, my total sales is always $29 million, which then can cause some issues because, for example, when I'm in high school, I want to see this divided by that, but in this case, I want the total sales to be total for this color only. I don't want this to be that total. I want actually this value to be divided by this value to give me a right percentage. Why should it divide by 29 million value? Well, we used all, and all is ignoring anything. Depends on the table that we have used. So if I go back to my expression, in this expression, you see that I have used all of this table. It is important which table you use within this function. Let me bring that definition one more time. Return all rows in a table, all row values in a column, ignoring any filters that might have applied. This means might have applied on that table or that column, right? So fact internet sales is a table that gets filtered by two other tables. Let's come here. This is my fact internet sales table. This table gets filtered by this table and by this table. That's actually what this relationship means. It means filtering. So this is getting filtered by these two tables. That means that if I say all here, let's say this is all. If I say all here, then this ignores any filter coming from here, ignores any filter coming from here. That means it's always the total. Now, I might want this to be different. I might want to say, I don't want this. I want the filters from, let me just draw something a little bit different. I might say I want this to be all, but only for this. I don't want the filters coming from this way to past, but still I want the filters from here, right? And you already learned that if I do all, it doesn't really care about that one. It puts the all here as well. But what if I use all of this table instead of all of that table? What would be the difference? The difference would be if I say all of this table, this means that this table is not filtered, right? This table will filter any other tables that is through their way. So it means that it filters this, but it doesn't pass this filter because this is a single directional from customer table to the sales table. So as a result, this is giving me exactly what I want, right? So let me show you that as another measure. I'll create a new measure. I see there's a question. I'll get to that question in a second. So I'm going to call this, let's say, total sales for product, something like that for now. And I'm using SumX again. Now I can say my table. In this case, my table would be all, but not the fact internet sales, all product table. That would be here. All dim product table. And then I can say sales amount, right? Or I can just use that measure sales here. When you use a measure inside another measure, just remove the table name before that. Now let me bring that over here. Okay, I think the reason is the measure that I used. Let me use that. Let me use that thing itself inside another function. I think it's better that if I explain it through this function for you anyway. There's a function called calculate. Calculate is like another type of function similar to SumX, different behavior, totally different behavior, but in terms of the way that they work in the total expression, they are different. Calculate is a function that you provide an expression and it returns the result of that on a filter. And I'm going to show you that on this because there's a little behavior difference in the way that SumX works in the aggregations that is a little bit different here, and the way that it works across multiple tables. So here I can say what is my expression. My expression is sales. So I want sales. And then I want it for a filter, and this filter can be a table. I can say this is for all dim product, right? So it's basically kind of the same thing we have been trying to say with SumX. This is just a different order. In SumX, you have table first, then expression. In here, we have expression first, then the table, and you can use multiple tables, right? So I'm using that. Seems it is not still considering anything here. Oh, I think I did it the other way around. I want dim product filter to come through. You see, even I sometimes get the mistake of where the filter context should come from. So let me bring that expression again. I wanted actually this to come through and filter this. The place that you want to filter, that place should be having all in the expression, right? So I can say in this case, I can say all dim customer, right? This means that ignore the filter for customer. Yep, here you see it is working. Ignore the filter for dim customer, and education is coming from the customer table. Ignore it. You see this returns everything the same for regardless of the customer, but accept the filter coming from the product. You see, when I change this, this is changing. So this would be always, in this case, this value would be always the total of here, and it won't be the grand total. Then I can easily say this divided by that to get the total sales for that product. And this should be like total sales for the customer also. That makes much more sense to call it this way. So the table that you don't want the filter of that table to be applied, use that table inside the all expression. And if you want this to be for all of the tables, one of the ways is to say that for all fact internet sales, or another way is to say all without a parameter. You can even do this. That's also a possible option. That means across all tables, all columns, everything in my model. That is also one of the variations that added like about a year ago into the all. So now I can divide this by that and get like a percentage that works perfectly fine, even with the selection of this filter. Okay, now let's see what questions we have. We have Vincenzo asking why you have 30% at the bottom rather than 100%. Is this because of the filter context? That is exactly because of what I mentioned here, because my total sales was total sales regardless of any filters. Filter coming from this table, this is English education table, filter coming from product table, regardless of any of those, that was $29 million. And when I divide that value by that, this is always less. And even the total of customer, this is the total of customer. Why we can say this is a total of customer, because this is where customer is not filtered. The filters of customer doesn't apply here, but still the filter from product comes here. That color filter still comes here, right? So this is a total of customer. Because this calculation was not the total for customer, this was like a grand total, that always resulted in 30%. But now that I use this calculation, which was saying that give me the total for customer, all customers was exactly there because of this. When I say give me the total of customer, then this divided by that would return correct value. Let me just show you in a very quick second. Here I can say sales percentage for customer, something like that. And I can say, in this case, this would be divide of sales by total sales for customer. And making this percentage, showing it here. And you can see that this returns 100%, right? So everything depends on the filter context, of course, but the way that we wrote those functions is a little bit different. I used all in a different context. This time I used all in a different context. Another question, could you use remove filters instead of all? Yes, absolutely. You can use remove filters. That's another function that can give you some kind of the same behavior. There are like differences as well. In every DAX function, there are like different ways of doing things. You could use remove filters. You could use other functions to do that. You could use things such as all selected. There are many variations of the functions. Here, I'm not just trying to teach you like one single function. This is how this works. I'm trying to teach you how to write these yourself. Like one of the things that I tried to explain to you was that when you are writing a measure, your measure should return one single value, but you can use some functions that returns a table, tabular functions. Tabular function can be used inside a scalar function to be served inside a measure. Now, all is one of the tabular functions, and you've learned that every function has this little explanation. This little explanation that explains what this function does. So any functions that you are using, you can just read that detail. Some of them are good explained, some of them not that much, so you have to try it and see how it is working. There are good resources online as well, which helps you to understand how that function works. And playing with the different parameters of the function is also helpful. And here you can see like how many, like all variations, few of those, you can see it here as well, all selected, all except. So there are really a good list of functions that you can use. This is called the concept of using a virtual table as well. Let me explain it this way. When you use a function that returns a table, a tabular function inside a DAX expression, you are using a virtual table. This wouldn't give me this result if I just said fact internet cells instead of all fact internet cells, right? So it means that I've literally created this table virtually in the memory for this calculation, only for that calculation. After that calculation, this table is wiped out, right? This is called like a virtual table. Now, there are ways to like make this a little bit sometimes easier to understand. One of the ways is to use things such as variables that can help to write your expression. Like, for example, when you have this inside another function, inside another function, inside another function, you might consider using a variable for that. For example, I could write it this way. I could say define a variable. The way that you define a variable in DAX is like this, var. This is one of the few things that you don't see in the IntelliSense pop-up menu. Those are functions, those are not variable itself. So variable, I can write the variable name. Let's say I'll call it all sales. Variable name should be all one word. As you see, I cannot have a space in the variable name. You can have underscore or things like that. Let me define it with underscore, and I can say this variable equals to this expression. So that means that at the beginning of this measure, I calculate this, write it here, and then when you have defined a variable, you have to return something for your measure, right? This is not returning something your measure. This is just a definition of a variable. So we have a return. Usually with variable definition, we also have a return. Now what we are returning, instead of all fact internet sales, here I can say all sales. And you see that recognize this variable. Now for a scenario like this, we don't really go to define a variable, especially when we used it only once in our expression. We use this approach if we used it multiple times. Like we said, sum x of this, then divided by something else, all of that happening inside this measure, and we reused all of fact internet sales multiple times. That is a really good example of creating a variable because it makes your code much more readable. This is easier to read. You read it like this, then you go and check what is this variable. And it also makes the performance of your code better, especially if you reuse this multiple times. You don't go and calculate it again and again and again. You just calculate it once inside your measure and reuse it. Variables are to be used only within the context of within that measure itself. You cannot use a variable in another measure, define it in this measure, use it in another measure. We don't have the concept of like global variables. These are mainly like local variables. Okay, I don't see any questions, so continuing on this again. So I can use this approach to calculate things such as conditional sum, right? Something like sum if you have used it in Excel, something like that. I can write it in a few different approaches. I'm going to show you like 3 different approaches, and with that I wrap up this calculation section, or let's say this session overall. Let's say what I want to do is to calculate the sum of sales for red products, right? I want to have a calculation here. I don't want this to be just the total of sales. I want this to be sum of sales for red products, and I don't want to go and add a filter that says this is red products, right? I know we can do that, and we are trying to learn how to write DAX here. So I can do it in a few different ways. One of the ways is this. I can say, let's say some sales, or I just call it sales products. Now, one of the ways is I can filter the table for red products. Now, there is a function called filter. I always recommend going and checking what all of these functions are. There is a DAX function reference. You can use DAX guide by Alberto Ferrari and Marco Rosso, great resources for learning about all of these functions. So filter, for example, is a function that you can filter a table. I can say filter the sales table, or I can say filter the product table, right? And then write my filter expression. So I can say filter product table, and then when the color is red. Well, this filters the product table. But then the thing is that how can I get the sales amount out of this? And this is not something I can use in a measure directly, because this also returns a table. Returns a table. You can see that returns a table where the filter with this filter. Okay, so this returns a table. I can use that inside a function such as SumX. From this table, now this whole thing becomes my table. From this table, I want to return sales amount, right? Or I can say the sales measure, right? But I don't want to do that. I just want to use the sales amount so that you can actually understand what's happening behind the scene. It doesn't understand that because this is the product table. It is the filtered version of product table, but still product table. And product table doesn't have a sales amount column, right? So that's a bit of challenge. What can I do? I can use that measure again, as I said, but I'm going to explain something different for you here. Another thing is that I filter the fact internet sales table, but then the problem is that fact internet sales table doesn't have the color in it. There is, for example, a function that allows me to pass from one table to another table. That function is called related. I can use this function to get a value from another table, right? How does it work? I just provide the column name. In this case, I'm in the fact table. You see, I filtered the fact table, But then when I use related, I'm saying that from the product table, give me the color column. Is this red or not? Right, and this would work fine. As a result, here I do have the sales amount, and it is just working absolutely fine. Let me bring that here so you can see that this is my table. Because this table is a filtered version of the sales table, but still filtered by the color red. And to do that, I used another function. You see, like a function inside another function inside another function. That's absolutely fine. In the world of DAX, you can use as many as functions inside each other. And this gives me the ability to navigate between those. As a result, all of this together is saying that first filter the fact internet sales table for all the product colors red. When you filtered that, give me the sales amount of that. So if I bring it here, if I bring it as a measure here, that should give me a subset of this, which is sales for red. And to compare it, I just filter here so that you can compare it yourself. For this visual, I set a visual level filter and choose red. And you can see this matches that. Now, this is not the only way of writing it. Actually, if some of you have been experienced in DAX, you might wondered why did I write it like this long? There is much better way of writing it. Yep, there is. The reason that I wrote it this long was to show you how functions in relating to each other works. There is actually a much easier way to write it. Let me show you that. I'm calling this sales red. It calculate this time. Now this time I'm using calculate function. So I'm calculating sales and I'm using the sales measure this time as well. So much easier. I'm not going to write sum of sales again. And my filter is color equal to red, just like that. Calculate is a function that is aware of the relationship between tables. It's not like SumX that you need to go and dig into the concepts and relationships. This, just as basic as this, will give me exactly the same response. Just copy it over here. And you see this is returning exactly the same thing. How does it work? It says that calculate this measure with this filter, and I can have many other filters as well. However, the thing is that this should not, let's say, make it, let's say, you confident that they are always the same. They might be different in a different context, because always remember, measures are evaluated in a context. They both look the same. Now let me do this. Let me say I change this to become a table. I change this to become a table. I'm going to add the product color here. Regardless of the product color, this would be always like this. I'm going to add product color here. This only shows red products, right? It is still the same number. I'm not saying that this is like, this is different number, that is a different number, but you see the view from the user point of view is different. And that is because the way that we used functions differently. In this one, I used the filter function which actually filtered that data. This one, I didn't use the filter function. So I said, whatever you are doing, I don't care. I'm just filtering this calculation for that table and let's return something about it. Right. I'm not saying this is good, that is bad. Both of those methods of calculations are correct and they can be used in different scenarios. I'm saying that when you are writing a DAX expression, there are different variations of writing the same thing. They might return the same result, but depends on the filter context, they might have different behavior. The main important understanding of this session is that understand the filter context in which you are writing your expression. If your expression is to be evaluated in a table like this with all other colors and you want to show this color, This is absolutely fine. If this is what you expect, this is also absolutely fine. It depends on what is your requirement. You might say, who is ever going to need that? In fact, you might need that. Why? Because you might want to say, what is the percentage of sales of this category versus red? I can do that. I can have sales like this. So then I can say this divided by that. That would tell me that black versus red, we had like this percentage. With this one, I cannot do that, right? So it really depends on the context, on the requirement that you are working. At the end, it depends on making yourself comfortable with using all of these different functions. Every function has a different variation, but there are mainly two types of functions. Tabular functions, those that returns a table, like this. Scalar function, those that returns a single value, like this, So make sure that you use them in the right combination. Always think about the filter context. If you consider those, then you know DAX in principles. You can start writing it. Your knowledge might be only limited in functions to work with. There are lots of functions in DAX, and some of them can be really complex to understand. But the fact is that you know the basics, you know the structure, you can start writing expressions and experiment and see how things are working. Another question, maybe it's out of scope. Can you explain the context transition in Calculate? Yeah, I think that would be a little bit like too complex for this let's say this level of session we are talking about. That might require another session to explain through, because I need to bring some like Calculate examples that shows how this transitions from one to another. But you can see like some kind of the examples of this here as well, which says that even here, despite the fact that this is white, we transitioned it, and this is working on the filter of red, right? So it's not really, let's say, rocket science thing. When we talk about context transition, it looks like a really complex concept, but in fact, it is the way that whatever the context is, I don't care about that. I'm going to change this to another context. You can do that with Calculate, but you can do that with other functions as well. You have seen that all with combinations of others can do that. Now, all is not really transitioning the context, all is like ignoring it, but then you can combine it with some other functions that transition it, like all selected, all like thing using these things like that together can work out of transitioning from one context to another context. Okay, that was pretty much everything I wanted to say. Just to wrap up, all of these examples that I showed you and many other DAX examples, I have it in my blog articles with the sample files. Go and have a check on those, download those. I have a DAX video course as well in or Radicad Academy with many other courses. We have over like 22 courses, 23 courses at the moment right now. Over 190 hours of video content. This is a $30 discount for the first month of Radicad Academy membership for your user group, so feel free to use it. That's pretty much me. If you have any other questions, feel free to ask.
Thank you very much, Reza. Been a very great session.
Thank you.
Let's see if there are any other questions. Let's give them some minutes. Anyway, we are very we have been very proud to have having you today with us. We are used to create a specific thread on our user group for people reviewing the session on the YouTube channel. And in case I think that they could post some question for your session, and we will try to reach you, I don't know, maybe via Twitter or LinkedIn and so on, and we will try to forward this question to you in case there are some more questions from YouTube reviewer.
Sure. Yep. Absolutely. Would love to do that. I'll be also watching that YouTube video link just in case any questions comes later.
Okay. Thank you. I cannot see any other question in the Q&A panel. You've been very kindly replying into all the questions. So I think that we can close the session for today. Again, I would like to say thank you very much, Reza, for being here with us. I know that it's very early in the morning for you, so you have a very long job day to do. So
Thank you.
Thank you very much, Reza. I hope to have you again in our user group session, and thank you.
Thank you.
Thank you, Reza. Have a nice day.
Thank you very much, Reza.
Bye-bye, everyone. Bye. Thank you very much. Bye.
Bye. Bye.